Dear ladies and gentlemen, welcome to my talk. My name is Igor Alexander, and I will tell you today a little bit about direct diode lasers for crash performance design in tailored property parts for the automotive industry. I'm working for Monocrom, and Monocrom is a medium-sized company that was established in 1993 in a village, in a city close to Barcelona in Spain. We are having a facility area of about 1,200 square meters, and 1/3 of that is dedicated to clean room facilities where we mount our laser systems, mainly diode lasers and their associated solutions. Besides having our headquarters in Barcelona, we are also active all over the world, having different distributors that are active in the marked areas here on the map. But besides that, we also have clients all over the world that are handled by us directly. So what exactly is Monocrom doing? Monocrom is specialized in laser diode packaging and making products out of the based on laser bars and their solutions. What we are currently can offer is wavelength regions from 405 nanometers to 2.3 micrometers and beyond. So we are also discovering the 3 to 6 micron regions, which will be all based on semiconductor lasers because there is our expertise based on. For the moment, we can deliver up to 250 watts in CW and in pulsed mode 1 kilowatt. Monocrom itself has different business lines, let's say, and our main business is focused on diode lasers, mainly laser stacks, actively, passively cooled ones, or single mounts, and then things that you can make based on laser stacks and mounts. So, for instance, we also have our own solid-state lasers. It's a smaller division, but still quite superb. And we also have pumping heads that can be used as building blocks for our customers that then build their solid-state lasers based on our pumping heads. The main focus today lies on direct diodes, so direct diode solutions that are, so to say, a complete solution where you can then apply the laser light from the diode to your worksheet. And besides that, we also have an electronics division that is focusing on driver electronics and monitoring stuff. But before I will enter or tell you more about the product that I would like to introduce, I would like to take the chance to tell you a little bit about our core technology, which is called clamping. So clamping itself is a solder-free mounting technology that allows us to mount the laser bars under room temperature, which has then some benefits. So clamping itself is quite simple. So we are producing a sandwich structure comprising 2 electrodes and the laser bar. So the electrodes holding the laser bar in between, and then you are applying a force for electrical and thermal connectivity, and this comes with some benefits, so to say. So first and foremost, we avoid any kind of mismatch in thermal expansion coefficients, which is good because we can avoid the so-called smile effect that is shown on the lower left. So here you see 2 pictures. The left side itself is a soldered laser bar as an example where you can see what smile is about. And then the right side shows you a beam profile or a picture of one of our mounts where you can see it is quite flat. So here we have a displacement of all the emitters of less than 0.1 micrometer, whereas soldered bars are in general a factor of 10 to 20 is higher than ours. Our mounting technology also comes with benefits if it comes to cooling, for instance, because we can extract the heat of the laser bar from both sides. And our mounts have a good thermal resistance that's below 0.2 watts per Kelvin. Having no smile is also one of the key factors for the products that I'm introducing, because you do not need to compensate any emitter displacement and can go straight forward, let's say, with simple optics to achieve good beam properties afterwards. So what's the product about that I would like to introduce today? So our DoForce modules are comprising two stacks. So the product picture is shown on the lower left, and some key figures are summed up in this table. So the module itself comprises two individually stacks, each of which can achieve 1 kilowatt in power and can adjusted and operated individually. So that means each module has two stacks and you can play with them to achieve the beam properties that you would like to get within certain borders, for instance. One of the main benefits of our technology is marked in red in the center of the table, which is a higher working distance. So if it comes to heating up complex three-dimensional structures, you are sometimes not able to bring the laser source very close to the surface, and we are overcoming these challenges with the higher working distance compared to competitor solution that may be focused or based on VCSEL technology, where you have smaller working distances. So this is one of the main benefits of our technology here that I would like to mark out. Regarding beam properties and what's the beam profile that is described over here can look like, is shown on this slide. So you have one stack beam profile and a two stack operation beam profile. The upper range shows you simulations, so that's, so to say, the best that you can get. And the lower section is illustrating a measurement of the beam profile itself. So each of the stacks has 9 bars inside to reach the 1 kilowatt. And at the working distance of 165 millimeters, we placed a sheet and then watched at the sheet while illuminating it with a camera to take up the picture of the beam profile. So as you can see, we are achieving our design goals, which was 40 millimeter and 34 millimeters in X and Y direction respectively. So the unit works quite good, and I would like to take the chance to show you a video of that, which is now playing. As you can see, heating up of the metal sheet takes less than 10 seconds, and we can achieve temperatures up to 650 degrees in less than 15 seconds with this module. So what is next? We can place up to 5 modules beside each other. So we can increase, so to say, the illuminated spot area up to an area of 200 times 34 square millimeters. And this area is then divided into 10 sections, because each of the 5 modules has 2 stacks inside. And then you can play a little bit around with different shapes that you would like to get within this overall illuminated area. Another thing that we would like to develop in the next, where we are already developing, is a control electronics to cover the modularity and operation function of up to 5 modules, as I have described. For the moment, that's the maximum that we are planning to deliver to supply. And we are also working on miniaturizing it a little bit while choosing different kind of industrial graded connectors, which is at the moment the main part that is determining the dimensions of our module. So this will be tackled in the near future, and the second version is will be a little bit smaller then. Besides that, we are also waiting for customers' feedback, which is always welcome, that we will introduce or incorporate the feedback from our customers in the new improvements of our following up products. And I would like to close the session with introducing some of the possible applications. So, as you already heard during the talk, it's about heating metals. So the module itself is made to heat up metals, and these can have different applications afterwards. So, for instance, you can increase the formability of different metals while you heat them up, which makes bending and stamping, for instance, easier. Where we also have different products dedicated to these lines. And you also can use it for stress release in, for instance, complex three-dimensional structures that are undergoing different steps in forming process and accumulate different stress. So if you then heat it up and you can release the stress, you can increase the overall accuracy of your formed parts. And yeah, to close the loop of the presentation and coming back to the title of my talk, one of the main focuses in general that you can generate designed crash performance of tailored property parts, which are standard nowadays in the automotive industry, where you can design a deformation pattern of your car if it comes to an impact of any sides and any directions. So I would like to take the chance to thank you all for your attention, and please feel free to visit our booth space that can be found under brand space as Monocrom. You also can write me an email or visit our website directly if you want. So thanks again, and hope to talk to you soon.